Hello everyone, my name is Krishnaveni. I am working as Assistant Professor in Marri Laxman Reddy Institute of Technology and Management in Department of Chemistry. Today I am here to tell about the water and its treatment. Some topics in this unit we will discuss today here. First, we will know about what is potable water. Potable water means the water which is helpful to drink. The water which is eligible to drink is called the potable water. Okay, the water which has the qualities to drink is known as the potable water. Okay, we will see water in the lakes, ponds, rivers, but those water we can't consume directly. Okay, the water which we will consume should have some specifications. Let's see what are the specifications of the potable water. Means water should be clear and odorless. The water which we will consume should be clear and it should be odorless. It should be pleasant in taste. The water which we are consuming should be pleasant in taste. Okay, and it is total dissolved salt should be less than 500 ppm. The water contains some amount of the dissolved salts. This dissolved salt should be less than 500 ppm. ppm means parts per million. It should be free from pathogenic bacteria. The bacteria which we cannot see with our eye will be present in the water. The water which we will consume should be free from the pathogenic bacteria. The turbidity in drinking water should not exceed 25 ppm. Means the water should now have more than 25 ppm turbidity. The optimum hardness of water must be 125 ppm and pH must be 7 to 8.5. The hardness we have discussed in the earlier chapters what is the hardness and what are the different types of the hardness. Okay, the hardness, the minimum hardness of the drinking water should be 125 ppm. Should not exceed 125 ppm. If it exceeds 125 ppm, it is not consumable for drinking. And the pH, you know the pH of the drinking water should be 7 to 8.5. Means from neutral to slightly basic. The pH should be from neutral to slightly basic. These are the some specifications of the potable water. Means the water which is used for drinking purpose is called the potable water. These are the some of the specifications we have to check before consuming the water. Next, treatment of the water. Before the water reaches our home, it will undergo some steps. Okay, we will see here what are the steps involved in the treatment of the water. Okay, first step is the screening, second one coagulation, third one flocculation, sedimentation, filtration, disinfection, and at last after these all steps the water will be distributed. Okay, these are all the steps before the water will be distributed done by the municipal water supply. And next we will see one by one. The first step of the water treatment is the screening. The water is passed through the screeners having large number of holes in it to remove the floating impurities. We know the screens will have the holes. Okay, when water is allowed to pass through these screens, what will happen? The large particles, the dust, the leaves, the large dust particles which are floating in the water will be primarily purified. Okay, and we will get the somewhat pure water. Next, after screening, the next step is the aeration. Aeration means it helps in the exchange of gases. We will leave the water without closing for some time to pass air through it. Okay, what will happen in this step of aeration? The gases will flow between the water and air. The oxygen content of the water will increase. The oxygen content of the water will increase. It removes the impurities like the iron and manganese by precipitating as their hydroxide. What will happen? The air contains the oxygen. Okay, the water contains the iron and manganese. It will be oxidized by the oxygen present in the water by the oxygen as their hydroxides. The iron will be converted into ferric or ferrous hydroxide. Okay, manganese also converted into manganese oxide or manganese trioxide or dioxide. Okay, this iron and manganese will be converted into their manganese hydroxides by reacting with the oxygen which is present in the air. Okay, this is the aeration step. Exchange of gases will take place and some metals will be converted into hydroxides by reacting with the oxygen. Next step is the sedimentation step. Here in this sedimentation step, at final, the precipitate in the form of sludge will be sedimented at the bottom of the tank. In sedimentation, what we will do, we will allow the water to settle down in a large tank, and here we will add some chemicals like alum, aluminum sulfate salts will be added. These alum salts will be somewhat gelatinous in nature, means they are some sticky in nature. What will happen? We will add these salts and we will settle down the water for some time. What will happen? This aluminum salts will form like the floccules and they will be settled down at the bottom of the tank like sludge. Okay, afterwards what will happen? This sludge can be removed. This sludge can be removed easily and we will get the pure water. Here we can see in this is the sludge formed by the mixing of the aluminum salts, alum salts to the water. After some time, if we leave like that for a few hours, what will happen? This gelatinous alum salts will form floccules along with the dust particles with the present in the water and they will be settled down in the sludge. This sludge will be removed and we will get the pure water. Okay, this is the sedimentation step. In sedimentation, water is left disturbed for a few hours so that the flock can be settled at the bottom as I showed previously. On average, 85% of the flocks settle at the bottom. The sludge of the flocks will be settled down as the sludge and it will be removed. Okay, this is the oral sedimentation step. And next step is the filtration step. Okay, the filtration is mainly carried out through sand filters. Okay, and we have two types of the sand filters, slow sand filter and the rapid sand filter. Here the main outlet of the sand filter is we will take 3 beds of the sand filters. Okay, first is the small granules and second is somewhat big and third one is the gravel. Means different sizes of the sands will be taken in 3 different types of the beds. Okay, in first we will take very minute small sand particles and afterwards somewhat bigger sand particles and last somewhat big type of stones, these are called the gravels. Okay, these 3 different types of sand filters will be present in the sand filter. Okay, here is the inlet of the water. When we pump the water to the sand filter, it will flow through the 3 beds and afterwards we can collect the water to the outlet. Okay, here the sand filter is the mainly used to filter somewhat the dust particles, minute dust particles. Here I told 2 types of sand filters are there, slow sand filter and rapid sand filter. Okay, what is the difference between the slow sand filter and the rapid sand filter? The slow sand filter will be not provided with the pressure inlet, but in case of rapid sand filter, the name indicates it is a rapid sand filter. The inlet of the pressure will be they're present in the rapid sand filter. Okay, the pressure will be pumped through an inlet pump so that the process of the filtration will take place fastly. This is the two main differences between the slow sand filter. In slow sand filter, no inlet of the pressure will be present. In rapid sand filter, here one inlet will be present to pump the pressure. Okay, this is the main difference between the slow sand filter and the rapid sand filter. Okay, this is the main picture of the slow sand filter. Okay, this is the raw water inlet, and here the sand bed is present, is the clean water outlet, clear water reservoir. Here the water will be stored, which is filtered, and afterwards the water will be filtered and we can collect the clear water after the filtration process. Here it is the rapid sand filter. Here we can see one inlet will be there to pressure the pump. Pump will be there to enforce pressure, so that the process will takes place fastly. Okay, this is the filtration step. And next, the last step is the disinfection step. In the previous steps, we have filtered the water, but we did not kill the bacteria. In these previous steps, we have not killed the bacteria and virus present in the water. This is the disinfection step where the bacteria and virus present in the water will be killed. They are not visible to the eye. Okay, we have to remove them so that the water will be safe to drinking. Disinfection is defined as using physical or chemical means to kill microorganism. Microorganism is nothing but the harmful bacteria, pathogenic bacteria and viruses, which will cause the different types of the diseases to us, like typhoid, cholera. Okay, and next, a disinfection frequently accomplished through the use of chemical disinfectants or via thermal disinfection, application of high temperature. We can use chemicals for disinfection or through thermal disinfection. Okay, thermal disinfection means generally the boiling. A disinfection process is considered to be valid if the device is usually cleaned for 6 long reactions in microorganisms can be shown. Okay, disinfection process will be valid only for some time. If we treat the water with some chemicals, it will be useful only for some time. After that, we have to again disinfect the water to use. Next, we will see the types of disinfection. Disinfection can be done by two methods. First, physical method, and second one is the chemical method. In physical method, heating to boiling. Next, incineration and irradiation with X-rays or UV rays. Heating to boiling means we know the boiling point of the water is 100 degrees. Above 100 degrees, the water will boil. Okay, what will happen? After reaching the boiling point, the water starts boiling. The microorganisms which are present in the water will be automatically killed. Then we can consume that water. Okay, next, irradiation with X-rays and UV rays. The water is treated with the X-rays or UV rays. Then the harmful bacteria will be killed by the X-rays or UV rays. Next, we will see the chemical methods like chlorination and ozonation. Chlorination means the treating of the water with the chlorine. Mainly, the chlorine is the main component in the chlorination in this chemical method. Okay, the process of utilizing chlorine as a powerful disinfectant. We know as chlorine is a powerful disinfectant. Disinfectant means the chemical, the substance which will kill the bacteria or virus is called a disinfectant. Here, chlorine is a powerful disinfectant. Okay, there are three types of chlorinating reagents. First one, by passing chloramines, by adding bleaching powder, and by chlorination. In these three steps, chlorine is the main component. We will see one by one. First one, by passing chloramines. Okay, the free chlorine react with ammonia to form chloramines, a weaker disinfectant. Okay, chloramine is a weaker disinfectant. Okay, what will happen? The chlorine react with the ammonia. Here we can see react with the ammonia, chlorine and HCl plus NH3. Chlorine and ammonia react and they will form the chloramines. NH2Cl. It is called the monochloroamine. Chlorine and amine and dichloroamine. Two molecules of the chlorine and one molecule of the ammonia, and trichloroamine, three molecules of chlorine and one molecule of the ammonia. Okay. If the water contains monochloroamine, it is good. If the water contains dichloroamine, it is somewhat better. But the water contains trichloroamine means it is bad for consumption. Okay. The hypochlorous acid, which is formed by the chlorination reaction, it will act as a disinfectant. Okay, HOCl, which is formed in the chlorination step, what will happen? It will be splitted into HCl and HO. O means it is nascent oxygen. This nascent oxygen will kill the bacteria and virus present in the water. Next, by bleaching powder, by adding the bleaching powder. This is chemically calcium hypochlorite. The chemical formula of the bleaching powder is the CaOCl2 twice and is chlorinated lime containing about 33.5% of chlorine. This process of chlorination using hypochlorates is called hypochlorination. When introduced to water, calcium hypochlorite reacts as follows. What will happen when the bleaching powder added to water? It is also will form the hypochlorous acid plus calcium hydroxide. The same way also, if we add the sodium hypochlorite, it will form the HOCl along with the NaCl. Here also HOCl, which is hypochlorous acid, it is very unstable. What will happen? It is very unstable and it will be converted into HCl and O. This is the nascent oxygen. This nascent oxygen is a powerful disinfectant. It will attack the enzymes of the bacteria and the virus. It will destroy the enzymes. How the chlorine will kill the bacteria and virus means it will react with the water and it will form the hypochlorous acid, nothing but the HOCl, which is the unstable product. This will be dissociated into HCl and O. O means the nascent oxygen. The single oxygen is called the nascent oxygen and it will have the disinfectant power. It will attack the enzymes of the bacteria and the virus. Okay, when the enzymes are attacked, automatically the bacteria and viruses will be killed. Next, chlorination. In this chlorination step, the process of applying calculated amount of the chlorine to water to kill the pathogenic bacteria is called the chlorination. Here, the chlorine gas will be pumped into the water. Here also, ultimately the hypochlorous acid will be formed, HOCl along with the HCl. This HOCl again dissociated into HCl and O. Already I have discussed this nascent oxygen, and this nascent oxygen will attack the germs, means nothing but the bacteria and viruses, and germs are oxides. Oxides is nothing but they are be destroyed. Okay, this is the chlorination step. And next one chemical method is the ozonization. Ozonization is a chemical water treatment process that involves the injection of the ozone into water to oxidize and remove impurities. Okay, ozone is made up of 3 oxygen atoms. That is a powerful oxidant. Okay, we know the formula of ozone is O3. It will be dissociated into O2 plus O. The ozone is a very unstable as it is a powerful disinfectant, but it is very unstable. It will be dissociated into O, means oxygen and nascent oxygen. Okay, this nascent oxygen we know it will act as a disinfectant and it will attack the enzymes of the bacteria and viruses present in the water, and it will kill the bacteria and enzymes, okay, so that we can consume that water safely. Okay, this is the ozonization process, but this process is somewhat difficult, means the ozone is highly unstable gas and it is somewhat costly. That's why we will prefer the chlorination for disinfection. In chemical process, the chlorination step is preferred. In physical methods, generally we will do the boiling. In household purposes, we can do the boiling. The water is heated above the boiling point. The bacteria and virus present in the water will be killed automatically. Okay, this is the ozonization step. I hope you like this session. Reference is taken by Engineering Chemistry by Dr. B. Ramadevi, Department of Chemistry, JNTUH. Okay, thank you.